Huh? To learn 8th grade math. Who cares about 8th grade math? Who cares? Why is it important? I mean, you're in algebra. Why do you care about 8th grade math? Why is it important? Yes, sir? Star, that is probably the third, not the most important one. There's 3 reasons. It's the 3rd reason. Yes?
Are we like pretty much skipping over it?
Yes. And still, why are you going to learn it? Why is it important? To help you later in math. It is going to show up on your accelerated math. That's reason number 2, actually. Number 2, because it is going to affect your grade, all right, for accelerated math. But what's the number 1 reason why we're in this class?
Isn't there a test over it near the end of the year? From some sort of
There's a STAR test. You've been taking those forever. That's reason number 3. This won't show up on an exam. Yep.
It's something that if you're not based on the SAT.
Yes. Very good. It has to do with the SAT. All right. It has to do with your SAT. And let me give you a little lesson in life, and we're not going to talk about this. You know. All right. The SAT. All of y'all are going to be in the top 10% of your class. Okay. And if you have older brothers and sisters, you know how important that is. All right. If you don't, you're going to know when you get to high school. Being in the top 10% of your class is very, very important, okay? Because that gets you into any college that you want to get into, except for Texas, because you'll be in the top 8%, all right? But any other school, top 10%, you can go anywhere you want, all right? So you're in. You're going to college, all right? But it's your SAT score that gets you money, okay? So what you're doing, the number 1 reason why you're in this class right now is to learn 8th grade math, because we're going to skip over it. You didn't learn it. You didn't get to it. You have 7th grade and you're going to skip to algebra. It's to do well on your SAT, because your SAT is what gets you money to go to college. So for the next 10 days, 40 hours, okay, you're working 40 hours for your college education. Does that make sense? To pay. You're making money. Does that make sense? That's why you're here. That's why you're here, is to make some money for your college education. And if you look at it that way, it's kind of like, huh, okay, I see we have a reason. Number 2 reason is correct. It's going to show up on your accelerated math. All right? So what you learn in this class is going to impact your algebra grade. All right? It's going to show up, and if you're not in this class or you're not learning what's in here, then you're going to do poorly on your accelerated math, and therefore you're going to not do well. You're not going to. It's going to be very difficult to maintain an A, and I know all of y'all want to maintain an A. And the 3rd reason is because you have to take the STAR test. Okay, and really that is the minimal reason in the big picture of things, because the STAR test, just y'all doing well on it, makes Mrs. Swanner and me look good. That's it. All right. Other than that, you know, it doesn't serve you any purpose. Does that make sense? So those are the 3 reasons why we're here today. Okay? All right. We're going to start with lots of vocabulary. So the first thing I'm going to give to you, let me make sure I have my list. What I want you to do is I want you to take this vocabulary list and I want you to put it into the spiral. All right? I don't care where, but you're going to put it in your spiral. There you go. We need more?
We need 2 more.
I can't count? That's okay. All right. Types of numbers. So the first thing we're going to talk about are the types of numbers. Tell me some names of numbers that you've heard of in the past. Don't look at your vocabulary list. Tell me some names of types of numbers that you've learned of in the past. Yes, sir.
Integers.
Integers. Very good. Do you know what an integer is without looking at your vocabulary?
Positive and negative.
You got positive and you got negative. Good. What else do you know about integers?
Can include fractions.
They cannot. Okay, they cannot. All right, so integers, that's a word you've heard. What's another word you've heard? Yes?
Rational.
Rational. Do you know what rational is without looking at your vocabulary?
It's any number, but it can be any number, but it has to. Okay. So it cannot be a repeating decimal. It cannot be pi. I can't believe.
You're correct. Pi is not rational. Help him out.
Let's be a terminator. Is that better?
One, it meaning
That's
terminating decimals are rational. Okay. What else? Yes.
Whole numbers.
Whole numbers. Yes. Whole numbers. Now, are whole numbers rational, or is whole numbers just another word that you've heard about?
I think they're rational.
They are rational. But tell me about whole numbers. What are whole numbers?
1, 2, 3, 4, and on and on to, I guess I'm
Yes.
Positive.
They're positive. No fractions or decimals. What makes something whole? What number makes it the set of whole numbers? Who knows? Yes?
1 and 9.
No. 0. Very good. 0 makes it whole. We're going to talk about that here in a minute. All right. What's another set of numbers that you've heard of?
irrational.
Irrational. What makes something irrational?
If it's not terminating, like, I think.
A decimal that does not terminate nor repeat, okay, is irrational. There's more to it. That's not the definition. But those are examples. What else? Yes?
Prime,
Prime. Cool. What's a prime number?
a number where its factors are one in itself.
Very good. Very good. Nice. What else? Or what other type of numbers do we have? Yes?
Is there an invisible number?
It's not invisible. Okay? It does start with an I. All right? It's called an imaginary number. Okay? We have imaginary numbers. Yes. Imaginary numbers, we don't do in Algebra 1, it's the square root of -1. All right? Because we know we can't take the square root of negative. So some mathematician said, hey, you can't do that? Let's just create our own little system. All right? And so, yeah, imaginary numbers are the square root of negatives. All right? Very good. Very good. Very good. So you've heard lots of things. Let's make sure that we really, really, really know what they are. Okay? Now, when you were 18 months old, 2 years old, and your parents were teaching you how to count, what number did you start with? 1. Did you go 1, 1.5, 2, 2.5, 3? No. How did you learn how to count? 1, 2, 3, 4, 5. Okay? Those numbers are called the, starts with a C. That? No. Because what we're doing?
Composite.
Go ahead and use your vocabulary words. No. It actually also starts with an N. It has 2 different words. The natural numbers. And what did I put it afterwards? Did I put natural numbers? The natural numbers are also called the counting numbers. Okay? Counting numbers. So the most basic set of numbers, okay, are the natural numbers. Okay? The natural numbers. And that is definitely 1, 2, 3, 4, ... Okay? The natural numbers. And we indicate the natural numbers with an N. Okay? Write that down. Alright, with N. Now, if I add the number 0 to it, what kind of numbers are those? Those are whole numbers. Very good. Those are whole numbers. Whole numbers. That starts with 0, 1, 2, 3, 4. And we use the letter W to indicate whole numbers. All right? So how many more whole numbers are there than natural numbers? There's only one more. All right? There's only one more. You add 0, it makes it a whole number. All right? Now, what about that other end of the number line? What about that other end of the number line? Integers. Very good. Now, integers is not an I, that's a Z. Okay? And they are like dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Alright, so those are integers. Those are integers. Here's a question. Are all whole numbers integers?
Yes.
Yes. Look at your vocabulary. Look at your vocabulary. What is the definition of whole numbers? Walker, read that for me, please.
The set of natural numbers and zero.
Does it say natural numbers?
Yep.
Okay. Cross out the word natural and write the word whole. Should say whole numbers and their opposites. It's a set of whole numbers and their opposites. Integers are the set of whole numbers and their opposites. Set of whole numbers and their opposites. Yours says whole or natural?
It says whole.
Integers?
Oh, you said three. You said whole.
Oh, whole numbers. Yes, I'm sorry. Whole numbers are natural numbers and 0, right?
Yes.
Yes, whole numbers are natural numbers and 0, and then integers are whole numbers and their opposite. Is that correct?
Yes.
Make sure it says it, okay. Scared me for a minute. Lordy. I make lots of mistakes, just a little FYI. That's not one that I would usually make. Alright. Okay, so how many more integers are there than whole numbers?
Infinite.
Twice as much, about twice as much. Very good. How many of them are there? Infinite. Okay, not infinity. Infinite. There's an infinite amount. Okay, there's an infinite amount. How many natural numbers are there? Infinite. How many whole numbers are there? Infinite. So infinity plus 1 is, what's infinity plus 1? Infinity. Very good. Infinity plus 1 is infinity. All right? Because there's an infinite amount. Infinity is a number, okay? How many are there? There's an infinite amount. Does that make sense? So whenever you talk about that, all right, when you're solving something, you're giving a solution, all right? The number, infinity, all right? But how many are there? There's an infinite amount. Does that make sense? Just a little extra. All right. So then we're going to go to rational numbers. Okay? Rational numbers. And there's no Coolio little symbol for rational numbers. All right? There's not. Now, read the definition, Caleb, of rational numbers.
A number that can be written in the form n over n, a ratio where m and n are integers and n is not equal to 0.
Very good. All right. So it has to be a ratio. Can I write all the natural numbers as a ratio? Yeah. I mean, 1 over 1, 2 over 1, 3 over 1, 4 over 1. Does that make sense? All right. What about whole numbers? Can I write all the whole numbers as a ratio?
Yes.
Yes. Can I put 0 over 1? Yes. Can I put something over 0? No. That's why in the definition it says m over n, and n cannot be 0. All right. It says that in the definition. All right. We don't allow n. We don't allow 0 in the denominator. Are all of my integers rational?
Yes.
Yes. Okay. So the rational numbers, all right, is the set containing all the natural numbers, the whole numbers, all right, that, and